using Python and understanding Python using Grok. Welcome back to the stream and welcome if you're watching for the first time. Thank you for joining in, and even if you're watching the rerun, thank you for watching that. And let's get started. We are live on Twitch, we are live on YouTube, and we are live on X. So you can join us on any platform of your choice and view me there. Awesome, let's get started. Let me just open up the windows and arrange things. Awesome. So now we have Grok open. We have our Leetcode open. We have our study plan that we are following. This is just a good list to follow because they have arranged all of the questions that you need to solve to cover most of the topics in a single concise list of 150 questions. And we are going sequentially from top down. We have already solved array and string questions, and we have solved two-pointer questions, sliding window questions, matrix questions, and hash map. We are currently on hash map. We are leaving the hard questions for last because they take more time and energy, and I don't want to dwell on those for too long. We will cover them at the end. So let's get started. Our target for today is to solve at least these three questions to some happy number and contains duplicate part 2. And then let's see if we can also reach the longest consecutive sequence question. This is a medium one, so if we can solve all four of these, that will be great. The target is ideally to solve at least the three of them. Let's see how much we can experiment, because if we find newer and newer ways to solve these questions, we'll just focus on learning that instead of handling more and more questions. We'll start with two sum. We all have solved this question. It's the question number 1 in Leetcode. So given an array of integers num and an array target, return the indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. So we have to find which two numbers add up to this target, and then we can return the indices of those positions. So position 0 and position 1 in a list, and this can be 0, 1 or 1, 0. So this is just a quick, we already know that if we go brute force approach, brute force approach will take O of n square time, because first we will iterate for each of these numbers. We will check if any of these match or not. So this will take O of n square time. And to save time, what we have to essentially do is we will go number by number. We say the current number is 2 and our target is 9. So we will check if there is a 7 in the numbers we have seen before. If there is a 7 in the numbers we have seen before, then we have essentially found our solution, because 2 plus that number will give us the result target 9, and we also have to keep track of the indices. So let's create a map. Let's just call it an element map or just map, or we can call it an element map, just because you can call it anything, obviously, for each of the numbers, but we also need indices. So let's go for I in range and length of numbers. For each of these, we will check required is the number we want. It is target minus nums of I, and then we check if required in element map. Then we just return a list of element map required and Ri. So if we find that we have already seen the required element, so for 2, we have already seen 7, then we will just return the position of that 7 and our current index. And at the end, if we do not see that, then we have to add the element to the element map, and this will be current number, so nums I is equals to I, and then we return each input has a one solution, so hopefully we don't get here. If we get here, we return 0 and length of nums minus 1. No particular reason, you can return anything. Ideally, we should be already have the required answer from here, and we never reached this point, but let's try running this. It works on the test cases. Let's try submitting it once. It works correctly. Now I think there might be other ways to just do this in one line and stuff. Let's see what other people have done, how they have approached this. I'll go with the solution posted by this person. They present answers in an easy to understand manner. So first, if we go by brute force approach, this will take n square time, but it explodes very quickly. It is a high time complexity that we want to avoid. So a hash map is a good option here. They have followed the same thing. They have created an index, then they are going over the numbers and indexes. So one better way to simplify this code would be to use the enumerate function. So for I, comma num in enumerate nums, we can get required as equals to target minus num. So we don't have to do nums I every time. And if required in elements map, then we just return our this line remains the same, and then we add this thing, but now we have num directly, so we don't need to rewrite this whole thing, and we can just return this. And even if we comment this out, it should work because we are already returning the correct answer here. Yep, it works. Almost everyone gets the correct solution. So let's just quickly move on to the next question. Happy number. Write an algorithm to determine if a number n is happy. A happy number is a number defined by the following process. Starting with any positive integer, replace the number by the sum of squares of its digits. Repeat the process until the number equals 1, where it will stay, or it loops endlessly in a cycle which does not include 1. Those numbers for which this process ends in 1 are happy. Return true if n is happy number, else false. So one way to solve this would be to brute force that while we have n, if it has more than 1 digits, then we can say like let's split those digits apart, square them, and then sum them such that we get a result. And we will keep doing this until we get a single digit number. Because when we get a single digit number, it's not possible to get a smaller number. And we also have to, I guess, check if it loops on itself. So if a number is two-digit number xy, and it also results in the sum of xy. I'm not sure if these numbers exist or not, but we have to check for these cases that it should our result should not go above. It can go above. So 1 and 9 square is 82. And then it goes to 68, then goes to 100, and then goes to 1. So if it results in the same thing, then we stop. Or if it's a single digit number. So if it becomes a single digit number, then we stop. And at the end, we can check if this is 1 or not. So first, we have to write a loop that we have to run it while it is a two-digit number or it's the same as before. Right. So how can we do that? I guess we can create a function to just uh, create a function to calculate the sum of squares, sum of digit squares, and then we can use that function to find out what is the next element going, the next step going to be. So what is it going to look like at the next step? So we can create next is equals to sum of digit squares. Right. So we will calculate this for n. And then while next is two-digit number, while the string version of next, or we can just say if next is greater than 9, because anything greater than 9 is a two-digit number. So then while next is greater than 9, or actually this solves our problem. Oh, okay. So this is like it's a two-digit number, or let me just see. While it's a two-digit number, or it is not equal to. So next is not equal to n. We will keep running this because our number should keep changing ideally. And if they are the same, then we don't need to work any further. We can stop. And if at any point at the next step, uh, next is not equals to n. So n is basically we are using it to track the previous step. If next is not equal to 1, or we can just return next equal to 1. This will return that our next step is, if next is 1 here, then we just return true. If it is 1 and it reaches here, obviously, because this both of these conditions will fail. But if next is greater than 9 still, so we get so first we get in with 2, it will be 4. So But the issue here is we can keep squaring these and it will go 2, 4, 6, 8 and then just explode. So we don't want to do this for like single digit numbers. They will just keep on growing because it will go 2, 4, 8, and then they will go 16, and then it will go 1 plus 36, which is 37, and then it will go 9 plus 49, which is 58, and then 25 plus 64, 89, and I don't know how much this grows, so I guess this approach is not ideal. We need some other way to verify whether these will end up at 1 or not. Because this can go pretty far and this can get stuck in like an infinite loop maybe. Sum of square of digits, and we can also have like very big numbers, so like something very big maybe. Because before I brute force this, I think there might be an easier way, a solution for this, for all the numbers that end in 1 in this way. So if we go with brute force, we just keep doing it until and unless it is not this, because even this condition fails because we need to do this for 2 as well. So until and unless it keeps looping, we have to do this. Next is equals to this thing. And we also have to update n. Temp is equals to n. Temp is equals to next. And then n becomes next. So basically we can do n becomes next and this becomes this. And this can go on for pretty long. So let's try writing this function, a number, and then for a number, we will go total is equals to 0 and while a number greater than 0, we will go total uh, current digit. Current digit will be we need 1, 9. So we need digits 1 by 1. If we divide this, if we divide 19 and then by 10, it will give us 1. And then we can minus this. Can we do modulo? Yeah, we can do modulo to get the last digit. Right. This will give us 9. So our number modulo 10. And then total will be current digit to the power 2 because we are squaring everything. And then our number needs to be updated to number divided by 10. So this becomes now 10. And then in the next iteration, it will become 0 because it will go 1. And then it will be divided and then it will go to 0. So at the end, we return total. Now I am guessing this will go time limit exceeded error. Again, it just got wrong. So let's see what happened. Let's print next and then print n comma next. Actually, let's print the same thing everywhere. So it's going to be n comma next and then n comma next. Uh, 19 and then 82. And then 82 comma 82. So till here we are correct. We are like 19 and 82. And then it becomes incorrect. It becomes 82. Okay, so we have to update this using the next. Because we already did it with n here. As expected, we get TLE. We just keep on going and going. Also, we should break while n is not equals to 0, next is not equals to n, or next is not equals to 1. Because at 1, we meet our condition and then we exit. So we get output limit exceeded. Let's comment this out. I'm guessing for the second case, we are getting TLE. Yep. So now we need like some simpler way such that we can calculate the sum of digits and how this works exactly. There might be some formula or maybe some easier way to end the loop earlier, and that can help. Let's see. Nets has not posted here. I guess no, he has. I think there are 2 points to solve this question. How do you obtain the digit in ones place? How do you move from the ones place to the tens place? That we have done. We do that pretty easily. And then we use those two ideas to calculate the happy number. We get the ones place, we get the twos place, and then we square it, and then we get the next digit. Get next number, we have done that. While n, we have done the same thing. While not n visit. Okay, so if at any point it goes to any previous number that we have seen, then we just break. Okay, so this is where things get a little bit tricky. We are only comparing that we were only comparing that it is not equal to the previous number. But what we have to ideally check is it's not equal to any number we have seen before. So let's just create a scene set that we have already seen this number. And then we can already add, or maybe let's just keep it empty here. We say we have already seen n, right? So, and also they are checking if n is equals to 1 here only. So let's remove this part. We get our next digit this, and while our n, we are not using next or any new variable. We are just updating the same variable. So while n not in scene, we just keep updating n, and we will add n, sorry, scene dot add n to the scene, and then we will check update n to be sum of digit. Uh, Actually, if it is 1, then what happens? Because currently they don't have 1, but the next will be obviously also be 1, so it doesn't matter that much. So it's okay. So sum of digit squares will be of n, and then we check if n is equals to 1, then we return true. Otherwise, we go back to circling the same number, then we return false. And they are saying that this approach will work. It works on the test cases. Let's also read the solution second, with the second approach they have taken. How do we quickly find the number 1? They can also use 2 pointers. What is the meaning of this approach? Because they are getting it 1. So they are just trying to avoid repeating the same thing in a loop, but that doesn't make that much sense. If you can easily achieve that using a set, you don't need a slow and fast pointer. So let's not do that. And let's just try submitting this code. It works. So great. I guess this is a valid solution, that we maintain a set of the things that we have seen, numbers we have seen, and then we calculate the next iteration. And if it's 1, we return true. If it is already something we have seen before, then the numbers will keep just looping, and we can avoid that situation by using a set. So this was great. The main thing to figure out was just like how to use a set properly, and also how to get from the ones digit to the next digit. Given an next question is contains duplicate part 2. Given an integer array nums and integer k, return true if there are 2 distinct indices in the array such that both of them are same. And under this case situation, so we have 1 and 1, and they both have a difference of less than 1. So we return true. And then again for this, but in this we have 1 and 1, but they differ more by 2. All of them differ by more than 2 indices. So we don't return true, we return false. And I guess we can easily solve this using a hash map. We are solving hash map questions. We can maintain the key and then values, all of them in a list. Or since we are iterating left to right, we only have to maintain the value of like last value. So last index, our key will be our element, and then we maintain the last seen index of that number. Because even if you see another, we have seen a one before this. This is the only one that matters, because if we see if this satisfies the condition, then great. Otherwise, next time we will only have to focus on this. We don't need to consider whether this exists or not. So we'll see last seen as our dictionary, right? And for each of the numbers, for I, num, and enumerate nums, we will go if we have the same number in last seen, then calculate the thing. And at the end, we will update the last seen dictionary of the position num with I. And then at the end, if nothing is found, we'll return false. So if it is already there, then we will say, what is the position of that? Let's get the last num position of the number. And if this current index minus position is smaller than equal to k, I guess, is it smaller than equal to? Yeah, it is absolute smaller than equal to. So here it was 0, 1, 2, 3. So it was 3 here, so we were returning false. But if it's 0, if it's smaller than equal to our k, then we just return true. We can also simplify this by like just mentioning it here, and we can remove this part, and we can also simplify it like if this exists and this is true, then return true. So we have simplified our if condition because it will only execute if this is true. Then it will move to the next part. Otherwise, it will end just at this point. Let's try running that once. We have an error. Last num is not defined. We have last seen, last seen, last seen, and last seen. So let's update that. It works on the test cases. Let's try submitting it once. It's a pretty slow solution according to them. Let's see if we can improve on it in any possible way. I think we have to iterate over all of the elements once. We need to maintain a dictionary, and we also need the index to find that this distance is not more than k. And we have to update this. So I don't think like we can go much faster than this, but let's see if what others have proposed. How are they doing this using a set? They are using the simple set as we did, I guess, right? They're creating a set, they are iterating over things, and then else, they're just using else, we are setting it every time. Because if we return here, you don't need else here. We only execute this when we don't return from here. Another one is two-pointer approach, a set approach, where we just add things to the set, and we found 0 at the index 1. If we have 0 in the set, we can return true, but there is no 0, just add 0 to the set. Okay. So we are also removing elements using this. Maybe set is a bit faster than this or takes up less memory, but I think this is an access operation we are performing, but let's see if this makes any sense. It's good to practice different approaches. So let's name this approach 1, named hash map. And then we will go with approach 2 of just using sets. We will add the element at the end of the iteration. We will remove the element that is out of range. Right, so first we'll create a set. So scene will be our only thing. So if it's scene, then scene. Then for I and num and enumerate nums, first we'll check if I is greater than k. So if we are at this position, k is equals to 3, then we need to get rid of 0. Greater than k. So if I is 2, then we don't need to do anything. If I is 3, then we need to do something. We need to remove scene.remove the element from nums, which we have seen before. Okay, and this only works because if you see consecutive 1, 1, then you will already have returned from this position and you never reach this point. Otherwise, suppose it was all ones and k was 2, and then we were just removing things. It will remove all the ones, but it doesn't matter here because we would have already returned that position before. Uh, if it is this, then we also check if our num in scene, if we have already seen this number still, then we just say return true. Right, return true. And then at the end, we add our number. And then if none of this passes, then we just return false. Just try running this once and then try submitting it. It works. It's still pretty slow. Let's see what other people have proposed. They are using the same approach. Just they have different execution time because Leetcode does something different for them. So this approach seems fine. We'll just use brackets. I like to use brackets in if conditions just to make things clearer and to explicitly state what is the order of operation execution so that I don't get confused and the program doesn't get confused. And this seems fine. Let's move on to the next question. Yeah, it just randomly went up, so it doesn't matter that much. And we have solved 3 questions that was our basic target today. Let's also read the next question and see if we can solve it today. Otherwise, we will handle it tomorrow, so no worries. Our next question is 128 longest consecutive sequence. Given an unsorted array of integer nums, return the length of the longest consecutive elements in a sequence. We must write a algorithm that runs in O of n times, so we cannot use like 2 different loops or something in a set loop or something. So O of n is our thing. The longest consecutive element sequence is 1, 2, 3, 4. We have 1, 3, 2, and 4, and then 100 and 200. And in this one, we have all the numbers. And in this one, we have only 0, 1, and 2. And we need to find. So we cannot sort it because that will go above. We cannot sort it because it will go above the stated time limit, stated time complexity. So then we have to keep track of what numbers are present. And we also have to find out which of them are consecutive. So when we see 100, what do we check? Is this one of the questions that goes uses like union and stuff, because we can have 100 and then we receive 4. They don't have any uh, thing that matches. So we don't say, then we receive 200, then we receive 1, and 3, and then 2, and then 4. How can we do this using a hash map or a set? For each number, maybe we can find if the previous or the next number exists and then just add it there. I group it. Right. So first we go 100 and then we say it exists in the set and it will be stored as a list, maybe. No, but that makes finding it a bit more difficult. So we can have a set that is with the element 100, and then we need to check. We get 4, so we check if 3 or 5 exists. So if 3 or 5 exists in the set, and then when we find it, what do we do? Because this is the only way to link to, the numbers before and after. So what we can do is, if we find it, let's just keep moving. Currently we get false. So our set just becomes 4 and 100. These are disconnected numbers. And then we get 200. So for 200, similarly, we check, we get false. And then we get 1, we also get false. So at this point, we have disconnected numbers. We have in our set 4, 100, 200, and 1. Nothing is connected. Then we get 3. And for this, we know 4 exists, right? So the existence of 4 is confirmed here. So is there a way we can group this with 4? Maybe we can go, since 4 exists, let's create a separate set which only has combinations. So this will be a set of 3 comma 4, and then when we receive but we need to be able to append anything from this side or this side. So we need to figure out a way. I need to see the solution to this because I cannot figure out a way. Yeah, union find thinking process is one thing. Like, let's check. I think, like, yeah, the first thing I stated, union find, might work here. Are the values small? They go up to 10 to the power 9. So I won't call them small. Yep. Let's see. Uh, Our approach is, I guess, yeah, it would be easier if they were small. But yeah, we cannot sort the numbers because we need to keep the complexity uh, 2 of 1. We should return 4 because there are 4 consecutive numbers. So how can you know you start from 1? My strategy is to check n minus 1. For example, if n is 4 and n minus 1 is 3, we have an input array. If n is 4, then n minus 1 is 3. We have 3 in the input array. That's why 4 is not the start of it, right? We have to found on also sorry for the background noise. I have a lot of background noise today. It's always occasionally here. So what is he trying to say? Alright. So we have a set, we have the longest for each number in num set. If n minus 1 not in num set, then the length is 1. While n plus length in num set. What is this length? Length is this. Okay. Okay, for each of the numbers in the set, this they are going if the number minus 1 is not in the num set, this length is 1, while number plus length is in the num set, then the length keeps increasing. So we start with, let's try writing how this will work. So we have the base case of these numbers, and then we will go for 100. We'll check if 99 exists. If 99 exists, then we do nothing. Okay, so if 99 exists, then basically we have considered 100 as well. So we don't need to check again. So we will start with the smallest number. So 100 comes, we perform a check for that. 4 comes, 3 exists, so we don't perform a check for 4. Then 1 comes, this is the smallest number, there is no 0, so we can start from here. So this is, wow, how do people come up with these solutions? Genius. But yeah, so basically if we have to find out what is the smallest number in the sequence, and for that we just simply say, if there is just one smaller number than this, then don't perform a check because we will do it with the smaller number. So for 1, 2, 3, and 4, we will just only perform the check for 1. But for 100, we will see if 101 exists. And then if 101 exists, we will update the length to 2 and see if it exceeds the max length of or not. So we will have, yeah, union find is might be simpler in this case, but I find it like hard to implement most of the time. Most of the times when I'm implementing union find, it just confuses me. I have done it like whenever I get used to it, I do 2 to 3 questions of union find. It's not that difficult, I understand that. But yeah, it confuses me half of the time still. You do union find, see, and the code is longer, so I don't like that. Is there a Python solution for this with union and find? Let's go Python. No nested loops. Nope, this is a CPP. They're doing something else. Nope. Yeah, I do need to practice union and find, so that's a note I have to make for myself, that practice union and find. So we'll also do that, maybe practice the union and find solution. But let's try implementing the first approach that we just saw. Oh, thank you very much. Yeah, we implement the union and find, and then we go with. This is the first time I'm seeing the variable dad being used for union and find, but okay, fine. Size, default, S for E in norms. We define the first union, sets. Yep. And then max size values. See, it is a bit more complicated. Okay, let's just go with the first approach for now. We'll also understand that. So we'll go with max length is 0 initially, and then current length we'll define later. We have the scene set. If it's if I'm working with trees, I use par and that not to be confused. Okay. Yeah. Well, par short for parent makes sense, but that is like the new one I've seen for the first time. So that's like fun. I might use that. So we have the scene set, the num set, and this will be a set of all the numbers. And we'll iterate for number in num set. And then if number minus 1 is not in num set, we will say that, okay, current length is 1. And then while our num plus current length exists, so max length will be default 1. There is obviously going to be 1. So while it is in num set, we will update the current length to +1, and we'll update max length to be max of current length and max length. And then we will just, hopefully this calculates everything, right? We set the max length, we go for numbers, we iterate over all the numbers, we see if the smaller number exists, we set the current length, we check if the smaller number, if the next number is in the set. If it is, then we update this. And at the end, we should be able to just return max length. Let's try submitting it. Go from the test cases. Yep. Oh, wow, wrong answer. Nums can be empty. Oh, why did I make that assumption? Hmm. Then I also need like another thing here. I don't want to do that. Can I do? I guess I want to keep the same, and just if length of nums is 0, then just return 0. Not the most optimal thing, but okay. Yeah, it is also slow. So let's now look at the solution that you shared. Let me copy that. Oh, I already have that open? No? Okay, how do we implement union again? We say find the position of x and position of y, then we say if they are equal, then return false. If size of Rx is smaller than size of Ry, then we switch them. Where are we storing size? Okay, size is a default dect with the size of 1. Okay, and then we always add it to the Rx, and then size of the other one is 0. The parent of Ry goes to Rx, and then for find we say if x is not the parent of this. Wait, why have I not seen this like sentence before? Okay. So first we set all of the parents to themselves, then for each of the numbers in set, if is in the set. This is a complex solution. I might use Grok to simplify it. And sorry for looking like a little bit dumb, but yeah, it's difficult for me to understand for some reason. I am solving. Yeah, it is a straightforward way. I'm just having, for some reason, I'm having trouble to understand this. This line, what is happening here? If it is not, then find and update it. Okay, it's just written in a single line. Okay, who writes this in a single line? Okay, yep. And then again, like, we have the parent. And again, what we are doing here is we are going all the elements, and then if a smaller element exists, then we are updating it. So our parent is going to be the smaller number or the larger number. Uh, this is another part, like why are we doing e comma minus e? So we get here, we find both of them, both of the parents, and then if they are equal, we just return false. No, that doesn't matter. And if the size of one is bigger than another, then we just switch the variables, and then in the larger variable, the one with the larger size, we add the size to the second one, and then we update the size to 0, and then we update the parent of ry to rx. So basically, whichever one is the bigger set, we go with that one, and then we go max of size values. So we'll iterate over all of the sizes, or one if nums else 0. What? What is happening here? Okay, so in this we are saying max. Okay. One if nums is a thing, else 0. Got it. Okay, so this was I would still call it like simpler approach. Yep, taking care of the edge cases. And they could have done it in the first line, but they want to do it in the last line. So, okay. Yep, totally understandable. Yep. So, we have to implement the union, which will take two numbers. I would like to call them x and y. And then we need to implement find for x. And then we need to have a parent dictionary. And then we need a num set, which will be a set of all our numbers. And then we have the size array. So, or it was dict. I think it was dict, right? So we have to import default dict from collections, import default dict. It was default dict. And then I guess if we want 0, we go int. Otherwise, lambda 1 is to say like we want the 1 the size to be 1 as a default. Okay. And then we set the parent initially for all the numbers. So for all numbers in num set, we set the parent of the number to be the number itself. And we have the sizes. Then we go for each of the numbers in the number set. If there is a smaller number, so num minus 1, then only we need to worry about this. So num set, we do a union of those num and num minus 1. And then at the end, we just have to find the max length, which will be the maximum of sizes will be updated. So size dot values we will have in our values, or wait, how do you, or 1 if nums, this line is weird, else 0. So first you check like all of these. If this is empty, I guess then this runs. I have to see why do we use or here. Maybe it's because if this is empty, then we go here. Why does Python does not have a more elegant way to write this? But okay, return the max length, and then we go on implementing find. So if the parent of uh, x is not x itself, then we go that, then we make x is equals to the parent of x, right? And then we return x. Is this the correct way? We go to the parent. So if we have 1 and 2, we go to 2, and I guess when they become the same, then we return like, okay, we have reached the final point, and then we say this is the thing. And for this, we find the parent of x and the parent of y. Find x and then find y. If they are the same, then we just return none. They were returning false. I want to return none, so, because false might be confusing. Why are you returning false if there's nothing you need to do with it? Oh, here. Okay. Yeah. Why? Okay, so we go to the parent of, so currently if it is 1, yeah, but like in this case, we are not using that anywhere. So in this case, I guess it's, yeah, I just like figured that out. Thank you for commenting that. I would have gotten an error and would have been confused for a long time. So if the parent of 1 is 2, it will be just 2 and gets stuck there. Uh, if the parent of 1 is 2, yep. Uh, let's see if we write find. Then if I have a set of, just bear with me here. 1 and 2 are my elements. The parent of 1 is 2 and the parent of 2 is 3. And the parent of 3 is 3. Then if I don't write find, I will go the parent of x, the parent of 1 is not equals to x, and then I will update it to 2. So x will become 2. Okay, so as I said, like for some reason, this confuses me unnecessarily. Great, thank you for that. Else, if the size, now we have to consider sizes, we need to add it to the larger one. So if the size of parent x is bigger than the size of parent y, then it goes to, we have to flip them. Okay, what? This is just to simplify stuff, I guess, because we don't want to write two conditions. We just swap the variables. I guess so. So parent x is always the bigger one or the smaller one. Parent x. So if x size is smaller, then flip it. So we want x to always be bigger. And then we do the size of parent x. We append that to parent, the size of parent y. And then we update the size of parent y to be 0. And then we update the parent of y to be parent x. What? Wait. Okay, yeah, because this can be different. Okay, got it. Parent of parent y is equals to the parent x. And we have updated the size and everything. And you return true. I will not return that. I will return none, which I don't have to, right? Yep. Uh, the things that confuse me still. Yeah, I updated it to Rx as well, right? X is still the bigger one always. Yep. I will try running once because if I have written incorrect code, then I need to correct it first. It runs on the test cases. It runs on the submissions. Thank you so much for sharing the solution. My execution times on Leetcode is false. Yep. Thank you very much for sharing the very helpful YouTube link. Let's just move over to that.
About path compression.
Do I have audio sharing enabled? Can you hear
Now,
the
this
audio of the YouTube video?
operation is really what makes the union-find one of the most remarkable data structures, because it's how the union-find gets to boast in its efficiency. So let's dive right in.
Let's watch it on
But before we get started, it's critical that you watch the last video so that you understand how the find and the union operation work. Otherwise, you want some time, because with path compression, I'm almost certain it's impossible to achieve a data structure, or a structure that looks like this. Nonetheless, it's a good example. So now suppose we want to unify nodes E and L, or just unify groups orange and blue, but we have access to E and L, and that's what we're calling the unify operation on. Well, we would have two pointers that start on E and L, and what we would want to do is find the root node of E and find the root node of L, and then get one of them to point to the other.
Okay, yeah, I think that might be because I have my audio enabled as well. So let's try.
But with path compression, we do that, but we're also going to do something else. So let's start by finding the parent node of E. So E's parent is D, and then D's is C, C to B, and B to A, and then A to F. So we found the root node of E, but with path compression, here's what we're going to do. Now that
I think the easier way would would be just to read the subtitles, the captions for me, because like we can still understand it. Like, yeah, we need the pointer. You can hear me now, right? Can you hear me now? Oh, I think I messed up with some settings. I have to figure that out. Is it better now? No. Okay. Why is this happening? It's better? Awesome. Let's see if it stays good or it's trash. I might have to figure things out with like there's a lot of different settings, so let's see. Uh yeah, so basically okay. Um Let me see. I'm getting some audios. Can you hear me now? And also sorry for the background noise. I yes, still echo. macOS audio, remove. Why is all of a sudden we have echo? Okay, can you hear me now? Without the echo? Same. Okay, so I guess I have to figure that out very soon. I will do some recording and testing with that. But thank you for sharing the video. I will go through this. And yeah, I get the point that we have to point all of the nodes at the parent so that we don't have to do long iterations. But we are not updating itself, right? It's uh, we are just finding it, and then that is okay. So when we are assigning the thing here, then it gets assigned to the correct place. So like here, it makes the difference. They are all updated recursively. Okay, great. Uh, So thank you very much for sharing the solution link and the video link. I will watch them and go over the solution later. I have to go right now and also figure out the audio issues. So thank you very much again for joining. And I guess today we solved four problems. I was able to complete. Uh, let's see where we have the list. These four questions today, the two sum happy number contains duplicate in the longest consecutive sequence. Why is it not marked as done? Okay, so yeah, we did these four questions, and I will go over the solution that you shared. So thank you very much, and see you next time. Peace. Bye.